Today we're going to look at the derivative of ln of x. And as we all remember, ln of x is the natural log, so it's log base e of x. This is a very special logarithm that we use a lot in math. And so we're going to look at the derivative and then do some neat examples with the derivative of ln of x. So before we get into that, we need to determine what is the derivative of ln of x. So let's take a look at that. Right here I have graphed ln of x. And so what we're going to be looking at is if I put a point on this, we'll call this point B, and I can move it around. And remember, the derivative is the slope of the tangent line. So here's the tangent line. Now as you can see, when the point is between 0 and 1, the slope is a very large number. Right? So over here, for example, the slope is 25, so that y value would be 25. And as we move along, the slope gets less steep. So numerically, the slope gets smaller and smaller until we start approaching what value? Right? If I were to let this continue going, what value would the slope approach to? That's right, the slope would approach to 0. So now let's graph the derivative of this function. So I'm going to let this play, and you can see the derivative started out very large, and as we move, it gets smaller and smaller and smaller until eventually the tangent, or the derivative, is going to approach 0. So then my next question is, what graph does this kind of look like? What graph does this look like as I let this number get larger? So as I let this number get larger, what does this graph look like? Okay, that's right. This kind of resembles 1 over x. So here's the graph of 1 over x. And as you can see, it lines up perfectly, except for this side. It does not exist over here because ln of x does not exist for negative numbers. Let's keep that in mind. So then the derivative of ln of x is simply just 1 over x, where x is always larger than 0. Okay, so let's go back here. So there you go. So the derivative of ln of x is 1 over x, and that's without using the chain rule. If you would like to use the chain rule, you can substitute in for it and find dy dx, or dy du, and then du dx. All right, let's move on to example 3. So a line with slope m passes through the origin, and it's tangent to the graph of y equals ln of x. Okay, so a line with slope m passes through the origin and is tangent to the graph y equals ln of x. And for this problem, what I want you to do is determine the value of m. Okay, that's what I want to know. What is the value of m? Now this problem can be a little bit abstract, so what I want to do is to go ahead and take a look at the graph of the function. And I have that right here. So here's ln of x. Here's ln of x. And here's y equals mx, right? It'd be any line with slope m. So as you can see, they're not touching right now. What we want is to find out the value of this line so that what should the slope be in order for these to be tangent to this at one point. Well, you can see it's about right there, not anymore because now it's not tangent, but you can see it is about right here-ish. Okay, so our goal is to find it when it's right here. Okay, so let's put down some of the information we know. Okay, we know that the tangent line passes through the point 0, 0, So that's 1. Now to find slope, how many points do we need? We need 2 points. So we're going to let x equal a. So f of x is equal to ln of x. So f of a is equal to ln of a. So we get the ordered pair a comma ln of a. Well, now I have 2 points, so I can find slope. So m is equal to ln of a, it's y2, minus 0, y1, divided by a minus 0, x2 and x1. So you get the slope is equal to ln of a divided by a. So this is the slope of the tangent line through the origin. Okay? So now we need to find another, we need to solve for this because we can't have that as our answer. We need a numerical answer. So we also know that f of x is ln of a. So f prime of x is 1 over a. Sorry, these should be x's. So f prime of a is 1 over a. So using that information, we're going to actually determine it, because now we have the slope represented from 2 different ways, and we know that they have to be equal. So 1 over a is equal to ln of a divided by a. Now all we need to do is solve for a. Well, the denominators are the same, so the numerators must also be equivalent. So 1 equals ln of a. Now to solve this, we raise both sides to the e. I hope we did not forget our log rules and how to solve for them. So you get e is equal to e ln of a. Well, we know that e to the power of ln of a is just a, so e is equal to a. We're almost done. So our slope was 1 over a, so our slope then is 1 over e. Okay, and let's check that graphically to make sure it checks out. So we go back to our graph, and right in here, I'm going to go ahead and type in 1 over 1 divided by e, hit enter, and look, it intersects right there, okay, at one place. So if I zoom in, I can see it intersects right about here. Alright, so now what I want you to do is I want you to try one. It's going to be the same example, but instead of having 1 over, or ln of x, it's ln of x divided by 2. So go ahead right now, give that a try. Okay, good. You tried it, you got an answer. So let me just do it to make sure that we all get the same thing. So we know that if it goes to the origin, we have the coordinates 0, 0, and we have the coordinates a, ln of a over 2. This is because f of x is equal to ln of x divided by 2. So f of a is ln of a divided by 2. So now that we have 2 coordinates, we can find slope. So we know that m is ln of a divided by 2 minus 0 divided by a minus 0. And we get ln of a divided by 2 divided by a. Now I want to go ahead and simplify this just a little bit. So if you wanted to, you could write this as ln of a minus ln of 2 all divided by a. You don't have to. I think it's helpful to separate them, seeing as this piece right here, that's just a number, right? That's not a variable. That's a number. Okay? So I also know this is one representation of slope. I know that the derivative, or I know that f of x is ln of x over 2. So the derivative of x is going to be 1 divided by x over 2 times the derivative of x divided by 2. This is because we need to use the chain rule because there's an inside function. And so we get 2 divided by x, this is simplifying this mixed fraction, times the derivative of x divided by 2, which is simply 1/2. So then the derivative is 1 over x as well. It's a coincidence that it became 1 over x with the numbers canceling. This does not always happen. Okay, so now we've got we're almost there. So now you have f prime of a is 1 over a. So now we have two different representations of the slope. So we're going to set those equal to each other. So you get 1 over a is equal to ln of a minus ln of 2, all divided by a. So since the numerators are different and the denominators are the same, we're going to set the numerator equal to each other. So you get 1 is equal to ln of a minus ln of 2. So now we want to get the ln of a by itself. So we have ln of a is equal to 1 plus ln of 2. Now we need to raise both of those to the e in order to get the a alone. So you get a is equal to e to the power of 1 plus ln of 2. Just do a little simplifying. A is equal to e times e to the ln of 2. This is using our exponent rules. And you get a is equal to e times 2 because e to the power of ln reduce each other. So then you get a is equal to 2e. And we're almost done because now we have the value of a, but we need the value of m. So m is equal to 1 over a, so it's equal to 1 over 2e. And that's it. Easy peasy.